We are cruising right along and going to get into indirect measurement today. And so take out something to write with and your notes packet. And again, we're going to rename this as 8.03 because all of this is pre-work leading up to Module 7. This is not in the textbook. Your assignment will be some pages in your packet tonight. And our learning target is that I can find measurements of things indirectly. Okay, so not directly. We're not physically going out to measure trees and things like that today. We're just going to use similar figures and proportions in order to do that. So when it comes to vocabulary and what does indirect measurement mean? Well, it's a method that we're going to use today, or some might define it this way as a technique. And you use similar figures. A lot of times it's triangles, sometimes it's rectangles or other shapes. Use similar figures and proportions to measure. Very important to remember your labels today, okay? So let's just warm up here a little bit. It says triangles ABC and EFG are similar. I'm going to put a big old tilde, the similar symbol there. Find the length of side EG. So they've labeled it with X. All right, so there are a number of different ways you can set up a proportion. A proportion says two ratios are equal. So one way to do it, maybe you'll say 3 feet, the vertical side to the base has to equal 9, the vertical side to its base. You could set it up that way. Or maybe some people like to go this, vertical side 3 to vertical side in the big one, 9. Little triangle base, big triangle base. You could set it up that way. Either way, it works, and you simply cross multiply to solve. Or maybe you can see what the ending value is on these. Basically, regardless of which way you do it, if you cross multiply, you get 3x equals 36. And when you divide both sides by 3, x has to be 12 feet. Make sure you label it. Show your work. There are a lot of ways to do it, and I want to see how your brain is processing these. Now, when I look at this one, EDEFGHI, these two triangles are similar. Whew. Find the length of side HI. All right, the problem is, there's a missing label here, so let's make something up, maybe 5 inches, okay? All right, so I have this this vertical side, this long side, this on the slant, as well as this one. Write a proportion and solve. You could say 5 vertical is to the slanted side, 5 is to 7, as 8, the vertical side, is to x. Or you could, if you like to match up the corresponding parts, 5 corresponds to 8, so you'd say 5 is to 8, as this slanted side as to this one, 7 is to x. If you do it this way, 5 is to 8, as 7 is to x, make sure that if you're starting with the smaller triangle and then comparing it to the larger one, always start with the smaller one and compare it to the larger one. As you cross multiply and solve, you get 5 times x equals 7 times 8, which is 56. Divide both sides by 5. Aha, I will not get a whole number here. 11 1/5, which is the same as 11.2, and make sure we label it inches. There we go. Now, that's not so bad, but let's take a look at some of the more familiar ones, type of problems you'll be faced with in indirect measurement. Here's a building. It's 30 feet tall. It casts a shadow that is 75 feet long. So do you see here how we've got the makings of a right triangle? This is 30 and this is 75. Here's a tree And I don't know how tall the tree is, but I can measure the tree's shadow, which was 35 feet. So we are looking for this specific measurement. I'm not going to crawl up on the tree, get to the tippy top and drop some sort of tape measure. We're going to use indirect measurement. Call this X or T for tree, if you like. And you can set up a proportion. Something like 30, the height, is to the shadow for the building, as the height of the tree is to the shadow of the tree. Larger numbers, but the same process still holds through. So take 30 times 35 equals this cross product, 75 times t. And then we're going to divide by 75 to get t by itself. Now you'll notice I don't necessarily go through all this trouble of trying to figure out what I can divide out of here. When in my day, before we had a calculator, we'd just start factoring numbers out of here. So for example, 3 can go into 10 and 75, or 3 goes into 30 10 times, and into 75 25 times. And then I can take a 5 out of here. That goes in there twice. I can take a 5 out of 35. It's made 7. It's looking to me like it's 14 feet. Double check your math on the calculator, and there you go. All right, next one. I'm going to get my fancy papers to make sure I've got all this. There's a pond at the park, and she drew a diagram with the information she knows. She's trying to figure out how far is it across the park. So she drew this diagram, okay, and she's got it labeled this way, okay. Now, how wide is the pond? Now, here's where we have to be careful. When you see something that has intersecting lines like this, it's not just flip this triangle up. We need to spin this thing so that we get it in the same orientation. So let me take this baby triangle, and I'm going to draw it and redraw it next door like this. So here's the kicker. This is the 15 yards on top, and that corresponds to the width of the pond, okay? But this 9, when I spin it to get it in the same orientation, this 9 yards corresponds with this 36, okay? So don't think that, it gets confusing. I can't spin stuff in my head, so I'd rather set it up this way. This side, the 36 side, corresponds, well, we could do 36 is to the distance across, what do we call it, x, as 9 is to 15. And then go to town and see what you come up with. If you cross multiply 36 times 15, that's going to equal x times 9. To get x isolated, I'm going to counterattack multiplying by 9 with division, because 9 divided by 9 is 1. Now, here's the deal. I'm telling you, you don't always have to be grabbing your calculator, because if you know that 9 is a factor of 36, then this just becomes 4 times 15 over 1, which is 60. We are in yards, so there's your answer. Let's keep going and see what we can encounter. This is a little oops that got copied in there, so just ignore that. Here we have some shadow problems, okay? Here's a flagpole. Okay, we don't know what the flagpole is, so let's call that F. The shadow is 84 feet. This is a little fuzzy, but this is a child here, so let's call the child's height C. The child's shadow is 7. And then you have the big tree, which is 51 feet tall, and its shadow is 119. The first thing they ask us for is the flagpole. So I know the height of the flagpole is, I'm going to call it F. The shadow is 84. Height to the shadow. The tree's height is 51, and its shadow is 119. Shazam, here we go. Cross multiply to solve. F times 119 equals 84 times 51. To isolate the variable F, we need to do all this. Now, granted, it probably is far easier to grab a calculator at this point to say 84 times 51 divided by 119. But believe it or not, this works out nicely. 36 feet. Ta-da! There you go. And that makes sense because the tree at 51 feet, the shadow was a little bit more than twice that, because if I double this, that'd be 102. So it's a little more. If you doubled this, 72, yeah, it's a little more. Okay. Let's look at the child. The child's height to his or her shadow has to equal, use the tree again. That's the one we know for sure. Cross multiply and solve. This gets very, very kind of in a rhythm, or what we might start to call an algorithm. We're kind of doing the same procedure each time once you analyze your information. All right, when you go ahead and solve this one, the child is 3 feet tall. Ta-da! Cool. Let's see, here's another one, 2 situations. This one, they don't give you the dimensions on the tree, but they tell us here in words. The tree is 56 feet tall. This one says, how tall is the house? How long is the shadow of the tree? So I don't know how tall the house is. That goes from here to here. I'm going to call that H. It looks like this tiny tree has a relationship of 4.5 feet tall to a 9-foot shadow. Ooh, that's kind of nice. Do you see that relationship? This shadow looks like it's double. So I can tell that the house has a shadow of 72 feet. Go ahead, cross multiply, and figure out how tall the house is. I will set this one up, and then you go ahead and pause the video and check your answers against mine once you restart. I'm going to call the shadow of the tree S. Oops, and that doesn't go on top. The height goes on top, shadow on the bottom. All right, when you cross multiply this one, you should get 36 feet. This one, you should get 112 feet. All right, getting it? Get it? Got it good? Awesome. Make sure you're using labels. Make sure you're talking yourself through how you're setting things up. Your assignment is posted in Schoology. Show your work, label your answers. Good luck.